Okay, algebras, let's take a look at this cumulative test review. We'll do this in bits and pieces and parts. This first section is all about graphing. So what you need to do is look at each of these equations and identify, what are you looking at? Take a minute. So these signs here are our absolute value. So what we want to know is that graph has that V shape. Our transformations are going to be the same. This -1 is moving my X value of my start, 1 in the positive. This -2 brings it down. Because I don't have any value in front of the X, I know both lines have a slope with an absolute value of 1. So this line here rises at a rate of rise 1, run 1. This one, the absolute value is going to be 1, but the slope actually is -1. So we can look at our domain, which we know is negative infinity to positive infinity. Anything can go in. Our range, of course, nothing down here in the graph is included. So our minimum, -2, our maximum can go off however. When we talk about our minimum value, we need to put it in as a coordinate point, over 1 and down 2. Our maximum, of course, is none, because this graph continues forever. When we're looking at our zeros, we can go ahead and look at where the graph crosses the x-axis. Because it has a slope of 1, I can guarantee that this is going to be over 1, 2, 3, and -1. If I wasn't sure of that, then I would need to get out my graphing calculator. And if I got my graphing calculator out, I want to make sure you know where to find that absolute value. So when you go into your function screen, pressing math, arrowing over to number, and there's our absolute value. So we can say the absolute value of x minus 1, close parens, -2. I can look at the graph, and sure enough, that matches what I have. I can go to the table of values, and here I see my first 0, and here I see my second 0. I see my minimum. So that can always help my graph. Don't be afraid to always take a peek at what the graph looks like. All right, so when we talk about our intervals for increasing and decreasing, remember all those conversations are included in parentheses because that starting or stopping point is not included. So make sure these are coordinate points and these are intervals that do not include my start and stop. So where is my graph increasing? So when I look at an increasing graph, that means that as my x's get bigger, so do my y's. So that increasing conversation starts at this x value. Make sure you're using the x value. Starting at 1 and up to infinity, my graph is increasing. When I'm talking about a decreasing graph, I'm looking at where do my y's get smaller as my x's get bigger. And of course, again, it's a conversation with just x's. Negative infinity over here all the way up to, but not including 1. So remember, this is a conversation about x. Here is my end behavior. That's a conversation about y. Where is my graph going? And it's going to positive infinity both times. All right, take a look at graph 2 and we'll come back and talk about it. Okay, so let's take a look at our quadratic. I know it's quadratic because I see this power of 2 here. So I know that this is going to be a curved graph. This negative sign tells me it's down like a frown. This is in vertex form, so I know that this vertex is going to be to the left 2, and up 4. My domain is anything can go in it. And my range, be careful here, you have to list it from least all the way up to greatest. So when I list it from smallest to greatest, I know that my range is going to be negative infinity up to and including positive 4. So none of the graph is up here. It does a turnaround, so that makes this maximum here. Here's an interval where 4 is included, that's why it's boxed. Here's a maximum, which is an XY ordered pair. My zeros are where it crosses the x-axis. If you're not sure, you can go ahead and enter the equation into the graphing calculator. You can graph it to see what it's going to look like. You can go to the table of values, and you can see here's that vertex middle point, and then here are the zeros. Remember the symmetrical nature of the graph. When we talk about my increasing interval, where is my graph? Where are the y's getting bigger? And remember, it's a conversation of x. So from negative infinity all the way up to, but not including negative 2, make sure this is curved, my graph is getting bigger. My decreasing interval, starting at negative 2, not including it, just after, and then as my x's continue this way, that is where my y's are now getting smaller. My graph has a decreasing nature. And remember, these intervals are all about a conversation of x. Okay, my end behavior, this is a conversation of y. Both of the values are approaching negative infinity. All right, so our next one is also a quadratic, but it's not in the same format. So I know it's a quadratic because I see my 2, but it's not in vertex form. So in order for me to graph it, I'm going to look for the zeros. I can enter it into my graphing calculator, and I can go ahead and say x squared minus 6x plus 8. All right, so I can enter that into the graphing calculator. I can look at a picture of the graph, and I can see it's going to have a couple places it crosses the x-axis. I can go to that table of values, and I can look for and see there's that symmetric nature of the graph. So I know right away my vertex is at over 3 down 1. I know right away that my zeros are at 2 and 4. And I know that over 1 up 1, 2, 3, and I know over 5 up 3. There's that symmetric nature of the graph. I can go ahead and draw my graph connecting my dots. It's a quadratic function, so my domain again is going to be all real numbers. My range, if you look at where this graph stops, there's no graph down here, so all my output values are from where this vertex is on up. So my smallest value, and I can remember I can box it, is negative 1, and it goes all the way up to, but never including infinity. My minimum is going to be where my vertex is at over 1, 2, 3, and down 1, and there are no maximums, none. Make sure you write the fact that there are no or none maximum, that there is none of a maximum, not NA. NA means it doesn't apply. All right, our zeros are going to be at the points 2, 0 and 4, 0. My graph is increasing from my vertex point all the way up to infinity, and the x-coordinate of my vertex point is 3. My graph is decreasing all the way starting here at negative infinity and up to but not including 3. My end behavior is positive. Okay, so take a look at this next one, but look carefully so you can see what kind of graph it is. I see 1/2, so I know it's going to be a compression, but I have 1 power of x here, and check it out, 2 powers of x's here. So I know this is a cubic graph, which means I can count on it having that kind of a nature. My domain and range are always for a cubic graph, all real numbers, from -infinity up to +infinity. So when we talk about minimums and maximums, there are none. Well, there are no places where this graph stops or turns around. So when we go ahead and we look at its zeros, you can go back to the graph and say, hey, when x is equal to -1, there's a 0. That's where it crosses. And when x is equal to +2, there's going to be 2 zeros, so that's going to be that turnaround. That's going to be where this graph touches but doesn't cross the axis. So I can go ahead and I can graph, enter into the graphing calculator, 1/2 times x plus 1 times x minus 2 squared. And the interesting thing is, remember, this is factored form because I can see the factors. Once I see the factors, then I can know, yep, my graph comes up and bounces off. So I want to look at my table of values where those values are, and I can easily graph. So if I look at over -2 and down, 1, 2, 3, 4, 5, 6, 7, 8. I already have this 0 down. I have this 0, so I have 1, 1, and then I have over 0 up 2, and I have over 3, 1, 2, 3 up 2. So that's where I can see my graph comes up, crosses the axis, bounces, and then goes on to infinity. My zeros are going to be at -1, and my 0 is going to be at 2, and I need to make sure everybody knows that that is a double root because of this squared. My graph is increasing the entire time from -infinity all the way up to this local minimum or this local maximum. So here is this point here where it does a turnaround. So I look at 0 is where my graph stops increasing. At that point is where it starts to decrease. And it decreases during this section all the way up to this minimum at 2. Once it reaches 2, it goes back to increasing on up to infinity. So we have this interesting part here where my graph is increasing, my y's are getting bigger, and here my y's are getting bigger, but in here is that part where my graph is decreasing. When we're talking about my end behavior, as x approaches -infinity, so does my output. As x approaches +infinity, so does my output. All right, take a look at our next graph, and I see a square root graph. I can think about those transformations. This graph moves to the left 4 and down 2. So we can go to the left 1, 2, 3, 4 and down 1, 2. That's going to be our starting point. It's a square root graph, so I know it's going to be an eyebrow, not a snake. So we can go ahead and enter that one also into our graphing calculator. The square root of x plus 4, make sure you close the parentheses or arrow out of the radical, minus 2. So when I look at the graph, there's my starting point, and I can see it going up. I can go to the table of values for here's my -4 down 2. Here's my -3 down 1. My next integer coordinate is 0, 0. And then my next integer coordinate is 1, 2, 3, 4, 5, 1. And that should do it. That gives me a really good picture of where my graph is headed. So my starting point is going to be back 4 and down 2. My domain is going to start at that point. So it's going to include -4 all the way up to infinity. And my range is going to be a conversation about this point because it's never going to go below there. So this is an important -2 up to infinity. So the starting point of your square root graph gives you these two important values. All right, it crosses the axis at 0, 0, which is also the y-intercept. The x and y-intercepts are the same. It's increasing from the very start all the way to the end. But remember, we're going to use the interval notation with the parentheses where it does not include it. So remember, intervals are a conversation of x. So from an x value of -4 all the way up to infinity, my graph is getting bigger and bigger and bigger. There are no decreasing intervals. As x approaches positive infinity, so does my output. All right, so you know what's coming next. If I have a square root graph, of course, next I'm going to have a cube root graph. This one's a reflection and a compression because it's a fraction that's less than 1. My center point is going to be moved over 1 in the positive direction, but it's not going to leave the x-axis because I don't have a y vertical shift. So my center point is at over 1 up 0. I can't go ahead and just graph these next 2 points because of that compression, and of course it has that reflection. So I'm going to go to my table or to my graph and enter in this equation, the opposite of 3 divided by 4 times, and I have to go get my cube root function. So I'll go ahead and go to math, and I'll come over to choice 4. There's my cube root of x minus 1, close my parentheses. I can take a look at the equation, and I can see there it is going through my center point. And there's my snake. It's facing backwards because it was reflected over that x-axis. So my domain and range, always for a cube or a cube root graph, -infinity to positive infinity. And the same with my range. My zeros are going to happen at over 1 up 0. So when we talk about an increasing versus a decreasing interval, let's go ahead and graph this. Because I have my point at 1, 0, I'm looking for other integer values, and this is going to be hard to find. Over -7 and up 1.5. That might be the best I get. When I look at my over 9 and down 1.5, that might be the closest I have because of that 3/4 compression. It's going to be a long time before I get to an integer value. So where is this graph increasing? Never. So there are no increasing intervals. It is decreasing from -infinity to positive infinity. As my x approaches -infinity, I'm moving up to positive. As my x approaches positive infinity, I'm moving down towards the negative. All right, so this next one asks you for your transformations. How did this graph transform from its parent function? This is an absolute value graph. So we're going to start at the beginning, and we see, first of all, that is a reflection. We see that it's a stretch by 2. We see that I'm going to go left 1. We see that I'm going to go down 1. So my reflection, my stretch, my horizontal, and then my vertical shifts. All right, good job on page 1. Keep it up.